Hello, my name is Anacarina Acuña. I'm a scientist and undergraduate student with not only a goal, but a dream of becoming an environmental engineer. And this summer, I had the opportunity of working with CU Boulder through an internship with the series RECCS program. I worked under Santiago Nunez and Aditi Bashard to research how current urban development practices impact land cover change. Part of the reason this research is important to me is because I acknowledge we exist within nature as a part of it. And probably as a lot of you here today can relate and listening, I have a deep respect and appreciation for nature and life. So my project is focusing on Westro Gulch in Parker, Colorado, which is a current urban development site. And what's unique about this site is monitoring started before development began, and it has continued throughout the development. So usually with urban development, what we see is we take a green space and planners come in and decide what we're going to make the area into, and we convert it into things like buildings and homes. And usually throughout this process, a lot of the natural land that was there before development began is removed or changed and disturbed in some way. Contributing factors are a growth in population, the continued growth of business, as well as urban sprawl. So yeah, and these changes can be physical, chemical, and biological, affecting all of the surrounding life and plants and sediments. So my question was, how exactly is land cover change disturbed over the course of a year of urban development? My method was using the site at Westro Gulch and monitoring the land cover change over a year using drone footage and digitizing it in QGIS software. So I used drone and satellite images captured months apart. And yeah, uploaded it into QGIS where I then digitized the varied levels of disturbance and calculated those varied levels of disturbance and took the percentage of the site disturbed. That's me when I went to go visit the site, and this is my kind of setup at the office when I would go in. These are images from Westro Gulch of undisturbed land. You can see a lot of greenery, and in that first picture over there, there's actually a wild pronghorn that were roaming on the area. And this is an example of area that has already been disturbed. This would be classified as high disturbance. Here would be high disturbance, and then back here I classified that with the tracks more as roads because it's had heavy machinery driven over it. This is an image of month 1 of development. There was already some pre-existing disturbance due to human activity, but it was fairly light. And then we can see that to month 5, there's been fairly more disturbance, including a higher disturbance with roads. And then by month 11, we can see that there has been a large increase in disturbance of the area. And to further classify how I categorize disturbance, these are examples of what it looks like underneath the digitization of like high level disturbance, low level disturbance, or light disturbance would just be that maybe it had machinery driven over it, but it's still predominantly natural green that was growing on the area. And this is closer up. And then this is a breakdown of how the disturbance is made up from month 1, 5, and 11. For month 1, it was predominantly just light disturbance. And then we can see by month 5, we start to see roads and then high disturbance by month 11. And 9% of it was disturbed before development began, just due to human activity. And then we see a spike up to 22%. And at the conclusion of my study, 38% of the area that is being developed has disturbance to some degree. Yeah, and we could see that the biggest growth was 159% growth increase from month 1 to month 5. So my study showed a positive correlation between the progression of urban development at Westro Gulch and land cover disturbance. An inspiration was the watersheds at Clarksburg, Maryland, where they did long-term, over the course of a few years, monitoring of a couple watersheds. And they were able to link it also to hydrological changes. So discussion would be that this is an example of changes to a watershed's physiology over the course of a year. Monitoring could be continued throughout the development at Westro Gulch, since it's predicted to continue for another like 3 years approximately. It could be expanded to include the hydrological interferences to the water cycle, which my mentors are already starting on. That's what these images are, tracking like the rainfall in the area. And another way to move this forward would be if we could quantify how much land we're disturbing to produce how many urban homes. This can also be applied to help predict for hydrological events like flooding that we see a lot in urban development, because we don't fully understand how, when we change land, what that's going to look like for the water cycle and where water is going to start collecting. So with that knowledge, we could have smarter planning. It could be motivation to incorporate more preservation of natural land in original development planning. And it could be used for modeling tools as well as water management with a better understanding of exactly how we're affecting the water cycle. We're at a unique time in history where we understand our interconnectivity with the world around us and how our actions affect the environment, ecosystem, climate, and the water cycle. These hydrological interferences look like change to land cover, which affects runoff, infiltration, because the soil becomes saturated and we see flooding in urban areas. Hydrological changes have been correlated with land cover change, and as seen with my experiment, land cover change is directly linked to urban development. We've seen a push towards sustainability recently in engineering for green infrastructure, ecological planning, and infill development to prevent urban sprawl. Some highlights to take away from this talk would be that we need to change the way we think about events like flooding, acid rain, and drought, and get curious about understanding them so that we can make those kind of events work for us instead of being confused by the way they behave, to better understand them and make them work for us. And then improve our relationship with land and water, as well as balance and consider our needs and desires as we expand as humanity in moderation with the effects we have on the world around us. Because if we care about the future health of this planet, we do have to take responsibility and be accountable for our relationship to it, because Earth is alive and we're responsible for its health. And yeah, and I do just want to say thank you, Alicia and Carla, especially for meeting with us, every week. You're a huge reason that I'm here today, and I really appreciate the opportunity. Yeah, thank you. Thank you. Questions? Yeah. I'm pretty sure that it was an alluvial stream bed, so it's like not there year round. But it was no, it was part of the disturbance because I think I classified it as high disturbance. It was only there during the February 2024 mapping. Stream bed. The stream bed was light disturbance and the basin walls were high disturbance, yeah. Any other questions?
That was really awesome. When you're looking at the high disturbance classifying, is it just a visual classification, or are you looking at like specific values and values?
No, yeah, so this study was limited because I just used drone and satellite images. And then I went in and did the digitization myself. So there's plenty of room for human error. But I just classified it the best that I could, yeah, from light to high disturbance. Um, my mentors are continuing monitoring. I would love to be part of that project maybe in the future. Yes.
Have there been any studies that quantify after the construction is done, if any of these high disturbance or low disturbance areas go back to their natural, I guess,
Like physiology?
yeah, they're not.
Do you mean like after development of the homes? Like if the water cycle and everything goes back to behaving the same way, like adapts? I'm not really sure if that happens over time. That would be really interesting to find out. And I guess that would come out in the data with future monitoring. If, yeah, the land just like fixes itself on its own, that would be pretty cool. But right now, I do know it's like an issue in urban development, though, because we don't understand the direct correlation of land cover change with hydrological changes. So we do see like a lot of flooding, and then we have to go back and fix it. Any other questions? Okay, thank you.
Thank you so much.